In the last class, we were discussing functions. We looked at function declaration, function definition, function call, etc. And we also looked at how to pass variables, either one variable or two variables, along with the data types, and then work on those variables, right? So far, the kind of examples which we saw, when you pass a variable to a function, it basically creates a copy of the value, not the original value. So if you edit a variable inside a function, that will not affect the original variable outside the function. Okay, so let me give you an example. You remember, say we created this float function, right? So suppose or let's say not float, let's say increment. That is, I take a variable and I increase it and I return that variable. All right. Or suppose I won't even return it. I just increase it inside the function. Fine. So if you are not returning anything, you write void data type. If you are returning a particular data type, write that data type as the function's output data type. If you are not returning anything, then you just write void. Okay. So this function is not returning anything. It is just performing some action. All right. So what you can do is you can just write a print statement inside the function. The updated value of x is. Okay. In the main function, what you can do, you can create some variable. You can pass that variable to the function, and you can give a print statement. The value of x before passing to the function is so and so, and once you call the function, you again print the statement, the value of x after passing to the function. Okay, so initially you declared x to be 5, and then you passed it to the function incremented it, and then you came back to the main function. Now what will be the value of x? It is changed inside the function. Will it be changed even when you come out of the function? That is the question. Okay, so let us see what will happen. Any guesses what will happen? You see, I declared x to be 5, I printed its value will be 5, and then I passed it to the function. Now in the function, x will become 6. I print inside the function, the value will be 6. Now I come out of the function, okay, and I print the value of x outside the function. What will be the value of x now? 6 or 5? How many of you think it is 6? How many of you think it is 5? Okay, so let us see. You see, the value of x before passing to the function in the main function is 5, and inside the function it is updated to 6. Once you come out of the function, you again print it in the main function, it is still 5. It is not changed in the main function. So the x in the main function is different from the x inside the function, user defined function. Why? Because when you are passing x to the user defined function, you are not passing the original variable, you are passing a copy. So whatever changes are being made inside the user defined function, they are being made to the copy of x, not the original x. So once you come out of the function, user defined function, the original x will remain as it is. Okay, so this is called pass by value. All right, you are passing a copy of the variable, you are not passing the original variable itself. If you want to pass the original variable, you should pass its address, which we'll see later when we get to pointers. Okay, so normally any primitive data type, when you pass to a function, it is passed by value. That is, its copy is passed, not the original. But you can also pass an array to a function. Okay, like you can create a function which takes an array and adds up all the elements and returns the output, sum of an array. Or you can take a function you can create a function which takes an array and say reverses the array. Okay, so you can create different functions. Now, when you pass an array to a function, imagine if the array has 1,000 elements or 1 lakh elements or 1 million, 1 billion. If that is also passed by value, then an entire array is copied and that copy will be modified. But that is too much of hassle, right? It's memory waste, time waste, and many things. So usually when you pass an array's copy is not passed. Actual array is passed. Actual array in the sense only array's first element's address is passed. Okay, so you will understand this better when we get to pointers. So there is a difference when you pass a primitive data type and a derived data type. Within derived data types, arrays are special. So when you pass an array, it is passed by address. But when you pass a normal variable like int, float, etc., its value is passed. That is, its copy is passed. Okay. So let me show you how to pass an array. So let us say, I think it's better to write it fresh. So I'll create a function which takes an array, adds all its elements, and returns the sum of those elements. Okay. So let's name the function sum of array, and this function takes an array. It's an integer array. So how do you pass an array? You say int some array name and put brackets. Okay. So when you put brackets, it understands it is an array, not a normal integer, but an array of integers. Okay. Now you want to add up all the elements, right? Now you don't know the size of this array yet, right? Because you need to run a loop, right? You should say int sum equal to 0, and then for int I equal to 0, I less than some number. Okay, some number. And so we don't know what that number is right now. I plus plus sum plus equal to a of I, right? Right now we don't know what this number is. So you should pass not only the array but also its size, right? It will work even if you don't pass the size, but only thing is the function will not know when to stop. You can put an arbitrary number here. I can put 100 also here. It will work. Technically it will work, but logically, how did you arrive at 100? Right? You can put 10, you can put 100, you can put a million, anything you can put. But a more practical thing would be to know the size of the array. All right. So one way is, suppose I am passing an array of size 5. So I write a of 5, and here I write I less than 5. Okay. So the function will calculate the sum of the elements of the array, and finally what should I do? Return what? Sum. That's all, right? I add up all the elements. That value is stored in the variable sum. I return that variable, right? So I call this function, but before that I need to create an array. So I will say int, say I just give a different name. We can give the same name. It doesn't matter. I get the values from the user. Get the values from the user. Okay, now I got an array that is populated with some values. I give this array as input to the function. All right. And this function anyway returns a value sum to me. So I can directly print that functions by calling that function's value by calling that function. So function call itself will become an expression whose value is nothing but the value returned to that function. So I can directly say, so you see there are two ways. I can say int sum equal to sum of array b. Here you need not write b of 5. You should not write b of 5. Okay. If you write b of 5, it means only the sixth element in that array is being passed to the function. You want to pass the array's address, so you should just write array name. All right. This is, and then you print this sum. All right. That is one way. Another way is you need not even write these two lines. You can directly call this function inside the print statement, and that value will be printed, right? Because function call will do what? It will call the function, run the function, whatever value is the return value of that function, that will be the value of the function call. So you can directly print that value. All right. Previous line will also work. This will also work. Previous method will also work. This will also work. Okay. So let us run this. Some 5 values. Okay. So what will this be? Sum is 8. That's it. Right. Again, some other 5 values. 45. Right. Now, so this is one way of passing an array to a function. Now the same thing will work. So let me copy this. Even if you don't give any number, same thing will work. It's working. The only thing is, there is no way for me to know what array I'm going to work with. Okay, if you already know the array size, it is fine. So here instead of 5, I can even put 50. That doesn't matter. That will not, I mean, it will still work. Because whether you pass a of 5 or whether you pass a, what you are doing is you are passing the address of the first element of the array. You are not passing the entire array. Okay. So when you pass the address of the first element of the array, you are giving an anchor to the original array. So whenever you are making any modifications to this array and you come out, the original array is modified, not the copy. Okay. So right now I didn't modify the array. Fine. I will come to that in a minute. But right now, one thing which you need to understand is you should pass the array size in some way. It is okay even if you don't pass the array size, it will technically work, but logically you don't know where to stop. That's the only issue. So it is better to pass the array size either like this, but the problem here is this function will work only on arrays of size 5. Suppose I want to make this function more generic, because here the loop is running only from 0 to 4. Right? If I give an array of size 2 or an array of size 100, this loop will not work. I mean, it will not give the correct value. So I want to write a generic function which takes an array of any size n and gives me the sum of the elements of that array. So it should take array of size 10 and give me the sum. It should take an array of size 100 and give me the sum. So I want to write such a generic function, right? So our instinct will be to write int a of n and then change this loop from 0 to n minus 1. That will be our instinct, right? So let us try to run this and see. It is not working. It will give an error. Why? Because n is a variable. It doesn't know what n is. Whatever you give inside the brackets of a, that is not visible to that. If you want to give n, you should give n separately. Okay, so like this, we need to modify it, comma int n. So this n is the size of the array. So I'm passing the array's address and I'm also passing the size of the array. So this array has 10 elements, this array has 20 elements or 100 elements, whatever it is. Now the loop will run from 0 to n minus 1 and add all the elements and return that sum. Okay, so let us see. And here, I should change this also to be a generic array, right? Now it is not array of 5 elements. It can be 3 elements, 2 elements, 10 elements, 20 elements. So what should I do? If I create int b of n, and if I say I equal to 0, I less than n, will this work? No, because it doesn't know what n is, right? So first I should declare int n, and I should get this value from the user. So the user should first say how many values the array will have, and then give the actual values of the array. Okay, so first I should scan n from the user, and then I declare an array of that particular size. And then for those many values, I scan the elements of the array from the user. Right? So now let us see. Yeah. So this is b comma n. Okay. Yeah. So now suppose I want to give an array of size 3. So first I will say the size of the array is 3. Now I should specify the 3 elements. Say 1, 2, 3. Sum will be 6. So the function should return 6. Okay. Or suppose I want to give an array of size 5. I'll say array size is 5. And then the elements of the array are whatever, 9, 7, 6, 4, 1, 27. That's it. Now I can give 10, 100, whatever I want. So now the previous function, I made it more generic. The previous function worked only for array of size 5. But now I modified the function to work on any array size. Even if you give 100 or 1000 or million elements, it will add up all of them and print the sum. Okay. So the difference between both the codes, you see, if you are giving the number, you can give it inside the brackets. You have to give it inside the brackets if you know the number beforehand. If you don't know the number beforehand, you cannot give it inside the brackets. You have to give it as a separate argument. You cannot write int a of n as an argument. You have to write int a, the array name, and then the size of the array separately. Okay. But if you are passing a string, then you don't even need int n. You don't even need to give the size of the array, because whatever array you are passing, that will end with a null character. So your loop will go not from some number to some number. It will go from 0 until you find the null character. So in that case, you don't need a second argument, the size of the array. You just pass the first argument, the array name, char a brackets. That's it. Okay. Yeah. So let me quickly show that also. So here, suppose I take a string and I increment each character in that string and print it. Okay. So I'm not returning anything. I'm just modifying the string and printing it. So I'm not returning anything. So this will be void. And I say increment the string, and string means char. I don't need the size of the string because I will find it out myself, because it ends with a null character. All right. So here what we need to do, for int I equal to 0, while a of I, what should I write here? A of I not equal to null \0, increment I, and what do I do? Increment each character. A of plus equal to 1. So each character will be updated with the next character. Fine. I'm not returning anything. That's it. Fine. Okay. Now all I need to do is declare. You can give the same name or a different name. It doesn't matter. I can give the same name, a of say 20. So my max size will be 20. Scan %s a, and all I need to do is call this function, increment the string a. and either I can print it inside the function or, okay, so let us print it inside the function. Okay, so what we write here, the string in the main function. Okay, and the string in the user defined function. Okay, fine. I just say hello. You see, string in the main function is hello. In the user defined function is H became I, E became F, L became M, L became M, O became P. Each character is incremented by 1. So the array is updated. Now let us come back to the main function and print the array again. Will it print the old array or the new array? Let us see. Original array or the modified array? What will it print?
Modified.
Yeah, the string in the main function after function call. This is before function call. You see, it printed the modified string, not the original string. That is the difference between passing an array and passing a single primitive data type. If you pass an int or a char, the copy will be modified. The original will not be modified. But if you pass an array, copy is not created. The original itself is passed. And whatever modifications you make to the array in the user defined function, those will be reflected even when you get out of the function. The original array is modified. Okay, got the idea? So array is not copied. Normal individual variables are copied. Okay, so when you pass a single variable, that is passed by value. But when you pass an array, that is passed by reference. Basically, its address is being passed. You will understand what is the concept of an address when we get to pointers. Okay, right now I will leave it there. Now let's move on to the next topic, that is recursion. So you already know some recursive functions, right? Mathematical functions. What are they? Yeah. Sorry. Factorial. Yes. Yeah. Factorial. So what is the formula for a factorial? Yes. So n factorial equal to n into n minus 1 factorial. Right? The same thing. I can't put this exact expression in the program, right? Because this symbol has a different meaning in the program. So I write a function for that, right? So let us say I have a function called factorial of n. So that can be written as factorial of n equal to n into factorial of n minus 1. Right? Any other function you know? Recursive function. Mathematically. Some series. Huh? What?
2 into 2 power n minus 2.
Okay. Fibonacci series, right? So suppose I have a function, say Fibonacci fib of n equal to, what will it be? Fib of n minus 1 plus fib of n minus 2, right? So that is Fibonacci series, right? Now let us, can you think of a recursive formula for calculating the sum of first and natural numbers? Normally, calculating sum of first and natural numbers is just an iteration. You write a for loop for I equal to 1 to n, sum equal to sum plus I. But I don't want to use iteration. There is a recursion involved here also. So you can convert the same thing into a recursive formula. No, that is the direct formula, n into n minus 1 by 2, n into n plus 1 by 2. But normally, the formula for calculating the sum of n natural numbers can be seen as a recursion. Can you both get out? Yeah, both of you, please. Get out. Get out. You have been smiling constantly and you have been disturbing me constantly. Just get out. Quickly. You're deaf. Get out. Yeah, you both only. Yeah. So recursion for sum, huh? Yeah. Yeah, that's it. So sum of n natural numbers is equal to n plus sum of n minus 1 natural numbers. That is recursion, right? So you already know the sum of n minus 1 natural numbers. You just add n to it. You will get sum of n plus n natural numbers, right? So usually an iterative problem can be converted to a recursive problem and vice versa. So which one to use and when to use what? The distinction I'll just explain in a minute. So first let's understand how recursion works in the memory. Like I mentioned earlier, we have RAM and RAM has memory, like when it has consecutive sequence of cells. Now say when you want to allocate an array, some space is allocated in the RAM. Similarly, when you create a function, some space is allocated in the RAM. So suppose I have some function call, say f of n. Now this function is calling some other function, say f of n minus 1. Again, some space is allocated in the RAM for f of n minus 1. It's stacked in the form of a stack. When this f of n minus 1 calls f of n minus 2, new stack is created. Okay, and so on until you reach, say, some terminating condition f of 1. So every time a function is called, new memory is created in the RAM, new memory is allocated in the RAM, and that is in the form of a stack. So what is the difference between, so what is a stack? Does anyone know? Stack as a data structure or stack in general? Stack is what? Like a stack of books, right? So when you have a stack of books, normally, how does it work? When you are placing a new book, you place it on top, right? And when you are removing a book, you take it from top, normally, right? So stack works on the principle last in, first out. Whichever element is being added last, that element will be removed first. What is the opposite? Another data structure you can think of? Queue. So how does a queue work? First in, first out. So whichever element goes first, that element will come out first. Right? So these are the two basic regularly used data types, stack and queue. Stack is last in, first out. Queue is first in, first out. All right. So usually whenever you call a function, a stack is created. I'll not get into the details, but the point which you need to understand is every time a new memory space is allocated for every function call in the RAM, and the way it is removed is in the reverse order. So f of n calls f of n minus 1, this calls f of n minus 2, and so on. Finally, you end up with f of 1 or f of 0 or whatever terminating condition you give. Once this f of 1 is executed, this stack is removed and it goes back to the caller function. Then f of 2, f of 3, and so on, it will come to f of n minus 2. This will be executed and then this memory is freed. and it goes back to the caller function. Then this will be executed, this memory will be freed, it goes back to the caller function. Then this will be executed, its memory will be freed, it goes back to the caller function, it may be the main, int main. Okay, so this is again overall like a stack. Whatever you are creating last, that is being removed first, right? First f of 1, then f of n minus 1, f of n minus 2, and finally f of 1 is created. So you remove them in the reverse order. F of 1 you delete, then f of 2, then f of 3, and f of n minus 2, n minus 1, f of n. So you remove that space in that order. Okay, so the thing here to notice is there will be a lot of memory usage in recursive functions, right? Every function call is creating a new stack or a new memory location in the RAM. So a lot of memory needs to be created and memory management needs to be done. So even if the function is slightly larger, the memory becomes exponential. The memory usage grows exponentially. So that is the disadvantage with recursion. It is slow and it uses a lot of memory. But the advantage of recursion is it is human friendly. It is easier for humans to think and code in terms of recursive functions. Like you see, if you just look at these two, I just translated the same thing into this. I didn't make any modifications. I just replaced this with a function name, right? But in the same thing, if you have to do without recursion, what do you need to do? You need to write a loop for I equal to 1 to n, perform 1 into 2 into this kind of thing. Actually, you can't do even that. You have to say for I equal to 1 to n, perform I and I plus 1, right? So something like that. And Fibonacci is slightly more difficult. If you have to do it using iteration, you should move the arrow to the third element, add the previous two elements, then move it one more element right, add the previous two elements, move it one more element right, add the previous two elements, and so on. To write this in iterative manner is slightly more confusing and more complex than just using this recursive function, right? So recursive function, they are more human friendly. It is easier for us to think and write in terms of recursive functions, but it is complex for a computer to execute. Whereas iterative functions are difficult for us to think and write, but they are easy for a computer to execute. Okay, so that is the trade-off between iteration and recursion. So if someone asks you to just quickly give me a code for a problem, you can give a recursive code, but if then they ask you to optimize it, then you need to convert it to iteration. Okay, so that's the difference. Fine. So now let's look at some examples. Suppose let me take this particular function, sum of n equal to n plus sum of n minus 1. So what does it do? It calculates the sum of first and natural numbers. All right. So let's look at the pseudocode. So int sum, and this function will take an integer n, right? Any recursive function, you should first give the terminating condition, right? If you don't give the terminating condition, it will run forever. Like for instance, here suppose I start with 5, sum of 5 equal to 5 plus sum of 4. Then this will call 4 plus sum of 3. Then it will call 3 plus sum of 2. Then sum of 1, sum of 0, sum of minus 1, minus 2. So this will go on up to sum of minus infinity until you give where to stop. You should tell it where to stop. 0 is not a special number for a computer. It is a special number for us, right? So until you tell it to stop, it will not stop. So you should always give the terminating. It's like a loop. For a loop, you have to give the terminating condition, right? What is the beginning number? What is the ending number? Similarly, for a recursion, you should say where to stop. In this, the beginning number is n. The ending number will be 0, right? So I can go to 0. If I go up to 0, sum will be 0. I need not waste one more step. I can stop at 1. I go up to 1 and I say sum will be 1, right? So I'll check for the terminating condition. If n equal to 1, you return 1. because sum of one natural number is 1. All right. Else, what should I return? N plus sum of n minus 1. Right? Here I need not write else. Why? Because if I enter the if condition, I will get out of the function directly. This if condition is ending with a return statement. Return means you get out of the function. So it will never come here. It will come here only if this if statement is false. So you need not write else again. Okay? Yeah. And in the main, I just call this sum function. So I say print sum of say 5. All right. So let us do a dry run. Dry run means we are working the code on paper or in our mind. You're not executing it on the real machine. Okay. So let us start with say sum of 5. So it will enter this function. Is 5 equal to 1? No. So it will go to the next statement. It will try to calculate 5 plus sum of 4. So this expression's value cannot be calculated until we know the value of this expression. So it will call this function first. So sum of 4 will call 4 plus sum of 3. Then this will call 3 plus sum of 2. This will call 2 plus sum of 1. Is 1 equal to 1? Yes. So this will return 1, which means the value of this function will be equal to 1. All right. So now the value of this entire expression will be the value of this expression. So 2 plus 1 will be returned to this. So this will be equal to 3. 3 plus 3 will be returned to this. This will be equal to 6. 4 plus 6 will be equal to 10. 5 plus 10 will be equal to 15. Is it correct? Sum of first 5 natural numbers, is it 15? Yeah, it's 15. Okay, so let's quickly code it once. So I am calculating sum of first n natural numbers. I should first give the terminating condition. That is, if n equal to 1, return 1. Otherwise, return n plus sum of n minus 1. That's it, right? And I just call this function in my main function. Print sum of say 5. Right? That's it. Okay. I can check for some other value, say print sum of 100. That's it. All right. Any doubts? Okay, let's look at one more example. Let us define a function reduce. So what this function does, this prints the current number and then calls itself with the next previous number n minus 1. So can you guess what this function does overall? Descending order. Straightforward. What does this function do? Yeah, it prints numbers from n to 0 in reverse order. That's all. Same thing you can do easily in iteration. You just write for I equal to n, n to 0, print I. But same thing you are doing using recursion, right? You are printing and then calling the next n minus 1. You're printing that and then calling n minus 2 and so on, right? So all it does is it prints numbers n to 0 recursively. It's up to us where to stop. We can stop at 1 or we can stop at 0. All right. So let's look at the pseudocode. Is it returning anything? No. So what? So what is the return data type? Void. Void reduce int n. And what is the terminating condition? If n equal to, where are we stopping? We are printing from n to 0. So terminating condition will be 0. So if n equal to 0, what to do? Yeah, print 0 and then just return. You see, once I print 0, I don't want to do anything more. I want to get out of the function. I want to get out of the function, but I don't want to return any value. In that case, just write return statement. Okay. If you want to get out of the function somewhere in between the code without returning any value, just write return statement. If you want to go until the end of the function, then it does not matter whether you write the return statement or not. It will anyway get out of the function. All right. Return without any value will just get out of the function. So usually it is more useful when you want to get out of the function somewhere in between the code. If you want to get out of the function only at the end of the code, it doesn't matter whether you write the return statement at the end of the code or not, at the end of the function or not. All right. Here in the if statement, the moment we get 0, I want to print and get out of the function. So I'm writing return statement. I don't want it to go to the else statement. All right. And since this is ending with return, I need not write else here. So I can directly write, what do I write? Print n and then reduce n minus 1. Okay. So this is an example of tail recursion. So tail recursion in the sense, you see this else part, although I didn't write else, you can imagine this as else part. This else part is my actual code. This if part is only one case, one special condition, it will happen only once. But this else part is my actual code. And within this code, the function call, recursive call, is the last statement. So when the recursive call is the last statement in the function's code, that is called tail recursion. But if the recursive call is the first statement in the code, that is called head recursion. We will see head recursion example just in a minute. First, let's look at this. So this is tail recursion. All right. Now let's do a dry run of this. So let us say we start with reduce 5. Is 5 equal to 0? No. So what will it do? It will not, this condition is not true. So it will directly come here. It will print 5 and then call reduce 4, right? So it will print 5 and then call reduce 4. Is 4 equal to 0? No. So what will it do? Print 4 and then call reduce 3. Then it will print 3. It will call reduce 2. This will print 2. It will call reduce 1. Is 1 equal to 0? No. So what will it do? It will print 1 and then call reduce 0. So 0 equal to 0? Yes. In this case, what do? You just print 0. You print 0 and then you just return. You return to the calling function. What is the calling function? R0. Sorry. Yeah, you just return. Fine. Now you print 0 and you return calling function. So the calling function here is R1 actually, right? So here you printed 0 and then Yeah. So one way to understand is, so this expands into this. Okay, so this is done within this. All right, you printed 0, R0, within R0 you printed 0. Now you return. So after printing 0, what are you doing? You are returning. You are returning where? To the calling function. Calling function of return 0 is return 1, right? So you go back to return 1. So in return 1, this return 1 is called by return 2, right? So you go back to return 2. And then you go back to return 3, return 4, and then return 5. There are no statements after this reduce. So once you come back, you called a function. That function did something. It came back. Now in the current function, caller function, there are no statements later. So there is nothing to do. You came to the end of your current function. So you go back to your parent function. This happens with every function. That's all. All right. So let us quickly run this and see. So reduce is void n equal to 0. And 0. And return. And here, what do we write? Int n, and call the function reduce n minus 1. All right. In the main function, what do I do? Suppose I want to just use 5, reduce 5. How do I write it? Should I write printf reduce 5? Just call reduce 5, because print statements are inside the reduce function itself. You need not again write print and then reduce 5. Actually, it will not work because reduce 5 is not returning any value. So that will not have any value. So you can't print that. You're just calling that function. Whatever happens is happening inside that function, right? That's it. It's printing from 5 to 0, right? All right. Now let's look at same thing. I just change the order. Here, instead of giving the function call at the end of the code, I will give the function call at the beginning of the code. In the else condition. Else condition is my main code. If condition is not the main code. So now the reduce function is called first, and once all the reduce calls are over, then the printing will start. All right. Now can you guess how the output will change? It will be 0 to 5. All right. So let us see. It's 0 to 5. So let me give you the dry run. Let me copy this. Why is this here? All right. So here, what we will do, we will just change the order of these statements. I will put this statement here. Okay. And I will move these two up. So now this reduce function is called first and then printing is done. Now let's do a dry run. So suppose I say reduce 5. What will it do? Is 5 equal to 0? No. So it will first call reduce 4. So will it go to print 5? No, it cannot go to print 5 until it gets the value of reduce 4. But reduce 4, to calculate the value of reduce 4, you should first call reduce 3. And again, for reduce 3, you should call reduce 2. For this, you should call reduce 1. And for this, you should call reduce 0. Now, once you reach reduce 0, 0 will be printed. Okay, let me use different color. All right. So 0 will be printed. And then what will happen? You return. Right? So while coming back, so here you return. All right. So yeah. So now while coming back, this reduce 0 is called by which function? Reduce 1. So in reduce 1, once you finish reduce 0, it will come back to the calling point and it will print 1. So if you look at the code, how will it look? It will be like, suppose I say reduce 1, if 1 equal to 0, print 0, return. This is anyway not true, it will not enter this. Then what does it do? It will call reduce 0 and then print 1. This reduce 0 code is over. It went inside, it printed 0, it returned. So wherever point it is going out, same point it comes back. Now this function is done. Now it goes to the next line, that is to print 1. Okay, and then this entire function would have been called in by reduce 2. So this is, sorry, reduce 1. This line is part of reduce 2 function, right? So once this function is over, here the line will be print 2. All right. So while coming back, it will execute the commands after the function calls. Okay. So here reduce 0 was called by reduce 1. So once this reduce 0 is over, here it will print 1. Okay. Now reduce 0 is over. Reduce 1 was called by reduce 2. Reduce 1 is over. Now you will print 2. Then you come back to reduce 2. This was called by reduce 3. Reduce 2 is over. You print 3 and so on. Here you print 4. Here you print 5. And yeah, reduce 5 was called by the main function. So you will just go to the main function. All right. That's all. So now you see here the printing is done while coming back. In the previous case, the printing was done while going down. Right? So this is what happens in head recursion. All right. So let us, you already saw this output, right? So here, this is head recursion. The recursive call is given at the beginning of the code and all the remaining statements will be executed later. So here, how is the printing happening? While coming back. So what happens? It first goes to the bottommost function call before executing any other statements. And while coming back, it will execute the statements after the function calls. All right. So in tail recursion, it will execute the statements first and then goes to the function call. It will execute the statements of that function call and then goes to the next function call. So in tail recursion, the printing is done while going down. In head recursion, the printing is done while coming up. There is another case which is neither tail recursion nor head recursion. So let me put this print statement here. All right. So can you guess what is the output of this code? Yeah. So these statements, they will be executed while going down. All right. And once you go to the bottom up to 0, then while coming back, this statement will be executed. 0, 1, 2, 3, 4, 5. Got it? So the statements before the recursive call, they will be executed while going down. The statements after the recursive call, they will be executed while coming back up. So this is like a high level view of how recursion works. So let us see. You see, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5. When it enters 0, it's entering only once. You're not printing 0 twice. You just print 0 and then return. That's all. So it is printing 0 only once. All right. So that is one thing. Yeah. So I just need to cover one small thing. Variable scope. You see, I mentioned this earlier, but I didn't give an example. Suppose, like I said, if a variable is declared in a block, it is visible only inside that block. What do you mean by a block? How do you define a block in C? Yeah, any sequence of statements, if you put inside curly braces, that's a block. That's it. That's why a function is a block, a for loop is a block, and if block, else block, these are all blocks because they are all put inside curly braces. All right. So suppose I'll take an example. Let's say int main, and I say int I equal to 5, and I start a new block, and here I declare int I equal to 10, and I say print I close the block, and here again I give a print statement. So can you tell me what will be the output? This will be 10. Here it will print 10. What will it print here? Huh? 5. Because this I, which is declared inside this block, it is visible only inside this block. It will vanish the moment you come out of the block. In this block, this I is visible. All right. That is the difference. So let me show you the code. You see, this is the example. Here, I is declared to be 5 here. Inside the block, I is declared to be 10. So if you print it inside the block, it will print 10. Once you come out of the block, this I will vanish. Only this I will be visible. All right. So it will print 10 and then 5. You see, let me run it again. It printed 10 for the inner I, and then once it came out, it printed 5 because the outer I is 5. All right. So tell me what will be the output of this program? 10, right? Because inner J will not be visible, only outer J will be visible. 10. All right. What will be the output of this program? 10 only. Is it? Yeah. So let us see the output. It is 11. Why? What is the difference between these two codes? Inside, it is not declared again. It is assumed that J is declared outside. So that same J is being modified inside. All right. Only if you declare the J inside, it will become a local variable. If you don't declare it inside, if you are using it directly, then the system assumes it is declared somewhere else. It will look for that. So it will use that same J directly. All right. What is the output of this program? 0 to 4 or 0 to 5? 0 to 5 and then 10. Why? Because the second printf statement is not part of the for loop. You didn't put brackets. All right. And for the second printf statement, the I in the for loop is not visible. Only for the first printf statement, the I in the for loop is visible. Once you come out of the for loop, the I in the main block, which is declared before the for loop, only that is visible. All right. So 0 to 5 and then 10. All right. What about this? Sorry? 0 to 5 and 4. so straightforward, yeah. I mean, just yeah, yeah. It will print 1 indefinitely because every time the loop starts, it is becoming 0. So it will never reach 5. It will never come out of the loop. It's printing. All right. What about this? Will basically give an error because if you try to declare the same variable again, it will give an error. Suppose you write int x and again somewhere later in the code you again write int x, it will give an error. Same thing is happening here in the function call. You already know there is a variable I. You are trying to declare another variable with the same name. It will not work. All right. So first let's run this. You see it's giving an error. All right. So to remove this error, all you need to do is remove I. It will work. In the main function, I is 4. In the inner function, I is 10. All right. What about this? All right. So J is used. J is used here. So that's, yeah. No, not 18. 14 plus? No. Yeah. Yeah, it's 16. How? You see, first this I is visible only inside the main function. All right. Now when you say this function I, this value 4 is passed to what? This function. So in the place of j, you get 4. All right. This local I is 10. So when you add 10 plus 4, you will get 14 here. And then for this function 1, you're not passing I, but you're using I. So it should look for I somewhere. Where is that I? This I is declared here. So any I, any variable which is declared outside all the blocks, that is global variable. So global variable is visible for all the blocks. So if you don't declare a local variable with the same name, it will look for the global variable. Whenever you declare local variable, it will just use the local variable. Okay, in the main block, you declared local I, so it used local I. In the function, you declared j, I mean you passed j, so it will just use that. You declared local I, so it will use local I. But in function 1, you didn't declare I, so it will look for global I. Globalized value is 2. So 14 plus 2, 16. So these are called global variables. All right. So anything you declare outside, it can be variable, it can be function. Those are visible to all the blocks. Whether you declare a variable inside a block or even a function inside a block, you can't use that function outside the block. All right. Just, yeah, this we saw array with particular size and array with a variable size. You need to give the variable separately. And this we saw calculating sum of numbers recursively, and this also we saw reduce neither head recursion nor tail recursion. All right. So yeah, so there are a couple of concepts which I didn't cover in the lectures. I mean, very small, minor things. You will work out some problems in the tutorials. So those concepts will be covered in the tutorials, which are not covered here. You can ask your instructors to cover them. Just very few things. Get char, those kind of commands. All right. Yeah. So functions, we are done. Functions and recursive functions and passing arrays. we are done. Next lecture we'll start with pointers. Okay, so let us stop here.